Hi guys, in this video we're going to talk about the general topic of what's called aero pushing. Now in organic chemistry, aero pushing is an important sort of way to visualize reactions. And essentially it's a way to keep track of the movement of electrons in a reaction. There are some basic rules I just want to lay out in terms of aero pushing that I think will help when you're seeing how reactions work. In this class, we may not worry as much about mechanism, but I do want you to have a general idea of the way things kind of move when molecules react. So in general, when we talk about aero pushing, what we're talking about, or what we're going to use, is what's called a curved arrow. Okay, and what this curved arrow is representing is the movement of two electrons. Okay, and when we say the movement of two electrons, we're talking about actually the movement of them in space, possibly between two reactants to now form a new bond, or possibly where electrons can be sort of spread out across a molecule. In general, when we write this curved arrow, we always put the tail of the arrow near negative charge. Okay, and that could be near actual electrons or partial positive charge, or doesn't matter what that is, but I'm sorry, partial negative charge. But the tail of the arrow is always coming from a negative area and then going to the head of the arrow, which is going to be near positive charge. Okay, so whenever we draw a mechanistic arrow like this, we're showing the movement of negative charge to a positive area. Okay, so let me just demonstrate this for you. Let's look at a reaction that is very common, the reduction of a ketone. So if I use a reagent called hydride, okay, which is actually a hydrogen with two electrons, has a negative charge, and I were to now mix it with this compound, the ketone carbon, this carbon right here, is partially positive charge because it's attached to this electronegative oxygen, so the oxygen would be partial negative. So if I were to mix these two reagents together, and I want to use now one of these arrows, I'm going to draw from the negative area of the hydride towards the positive area of this carbon. So we would show that just like this. Okay, we would actually draw the arrow, and we use the word attacking the carbon. Okay, now as this happens, we would now be forming a new bond at this carbon. We know that carbon can only have how many bonds? 4, and it would be getting 5 here. So something has to give. In this particular case, we would then push the 2 electrons in the carbonyl up onto the oxygen. And this would result in the following product. Okay, now notice in this I've formed a new bond by the hydride attacking. Again, I'm pushing this from negative to positive. And in doing that, I need to now break this carbonyl bond. And so those electrons have to go somewhere. And they're going to go up and they're going to sit up on top of the oxygen. All right, so that's how we would use an arrow to sort of describe a mechanism of a reaction. And I'll be using this sort of convention throughout our class. I won't test you as much on this concept, but you do need to be able to kind of follow along with what's happening. You'll get some practice of this in our class as well. So don't worry too much about aero pushing, but I wanted to give you a brief introduction to how it works. Thanks.